Welcome. Thank you so much for getting up so early. I know it's not so easy. I certainly didn't find it all that easy. But thank you for coming. I will be telling you today about possibly the single biggest disconnect in health. And it's quite a shockingly big disconnect. I'm also, you may be able to tell that I'm not originally from this country, but I am not talking just about the USA, I'm talking about the entire world. There is a profound, fundamental, conceptual disconnect that pervades our health system, and I'm going to be telling you what it is and how we're going to fix it. In particular, how we are going to benefit from fixing it in the sense of improving and indeed maintaining our health in old age. So, that didn't work. Let me try that again. There we go. Woo! That's a little bit too. Here we go. So, I work on the biology of aging. I'm interested in doing something about it. And the reason I'm interested in it is fundamentally because aging is the single worst problem facing humanity as of today. And when I say that, what I mean is that it causes more suffering than anything else. At the end of the day, that's the way we can determine and define how bad a problem is. And of course, we have plenty of other rather bad problems, but let's face it, 110,000 people die every single day from the ill health associated with old age. 110,000 worldwide. That's more than two-thirds, about 70% of all deaths. And of course, in the industrialized world, it's closer to 90%. So that's pretty bad. And of course, the real problem is all of the disease and disability and decrepitude and dependence and general misery that precedes that. And of course, in most cases, that's a fairly extended period. So it's a pretty bad problem. And we have to ask ourselves, why have we been so unsuccessful in actually doing anything about it? Because let's face it, 200 years ago, it wasn't that kind of problem at all. It was like, most of us would die of other stuff. In fact, more than 1/3 of babies would die before the age of 1, even in the wealthiest countries in the world. And, of course, lots of people would die in childbirth and so on. And we fixed that by really elementary, simple measures, like, figuring out that hygiene was a good idea and, vaccination and really simple things. Even, just mosquito nets have saved an insane number of lives. So we have to ask ourselves, why have the aspects of age-related ill health been so much more challenging for medicine? And the answer that most people would give is this. Of course, you're not supposed to be able to read this slide. It just emphasizes that there is rather a lot that goes wrong with us during late life, and these things all go wrong at more or less the same time, which means, of course, that they interact and exacerbate each other. It's a little bit of a scary business, and most people would say that this is the fundamental problem, that there is so much that goes wrong that the sheer complexity of the whole business actually is overwhelming. And that is part of the problem, but it's not the main problem. The main problem is the disconnect that I told you I was going to tell you about. And the disconnect is here. If you ask people, in what ways can somebody get sick? In other words, if you ask people for a taxonomy of sickness, then they will say something like this. They will say, well, there's infectious diseases, that's column 1. And then there's genetic diseases, the things that a few of us inherit, and that's column 2. And then there are the chronic progressive diseases mainly associated with old age, column 3. Alzheimer's, most cancers, atherosclerosis, osteoporosis, macular degeneration, all that kind of stuff. And then, most people would say that way out here in the stratosphere, there is this other fourth category of sickness called aging itself, which consists of these rather nebulous, non-specific things like frailty and, sarcopenia, that's the loss of muscle as we get older, and immunosenescence, the declining function of the immune system. That's the way that most people would put it. And it is tragically wrong in one very important respect. And I'll tell you why it's so tragic. Most people would say this. They would say, well, because aging is this kind of weird category out there that's not disease, it's kind of off limits for medicine. That there's no way that we could ever actually attack it or even should attack it because it's natural and universal and, this is completely different from the diseases of aging, column 3 in the last slide, which are curable and, non-universal. That's how people think. But it's nonsense. This is what aging actually is. Now, I'm going to spend a little time on this slide because it's very, very important that you should understand what I'm saying. First of all, look at the middle sentence. Aging is simply the accumulation of damage. self-inflicted damage in particular. Damage that occurs and accumulates as an intrinsic side effect of the normal operation of the body, of our metabolism. That's all that aging is. It's the accumulation of self-inflicted damage. And the body can tolerate a certain amount of that damage and work perfectly well. That it's just set up to tolerate a certain amount. That's why people up to the age of, let's say, 40 or 50 are working pretty much as well as they did when they were 20 or 30. It's simply the nature of the way the body is set up. But here's the thing. Everything I just told you about the definition of aging could equally be used as the definition of the aging of a car, or an aeroplane, or any other inanimate machine with moving parts. In other words, the top sentence, aging is a consequence of physics. Aging is not an emergent phenomenon of biology, like, consciousness or stuff like that. Aging is simply a phenomenon of physics. There is no fundamental difference between the aging of a car and the aging of you and me. And that turns out to be a really important thing to get into your head, because it tells us what to do about it. If we use biological terminology, then we can say this. We can say that metabolism, which is, of course, the network of processes that keep us alive from one day to the next, causes damage throughout life, even starting before we're born, and that damage is essentially harmless for a long, long time, but eventually, late in life, the damage reaches a level of abundance that is pathogenic, and we get all the problems I mentioned earlier. That is all that aging is. And, of course, our goal, as I've tried to depict with these arrows that have a slightly strange shape, is to separate metabolism from pathology, to try to weaken that link. Now, this is the way that we ought to be thinking about the problem. You will see that this table looks rather like the table I showed you earlier. And in fact, if you look closely, you will find that all four of the columns are the same as they were in the original version. We still have infectious diseases, genetic diseases, diseases of old age, and the stuff on the right, the non-specific things. But the difference between this version and the version I showed you earlier is the location of the big, thick black line. That big, thick black line is now between columns 2 and 3 rather than between columns 3 and 4. And that turns out to be a fundamental correction. Here's why it's so important. There are two reasons. First reason is it tells us that there is a huge disconnect with regard to the way we are currently addressing the things in column 3. We are spending fabulous, eye-watering amounts of money trying to deal with those things, but we're doing it under the assumption that the things in column 3 are rather like the things in column 1. In other words, that we can cure them. We can eliminate them from the body in the way that we might eliminate an infection, which is obviously complete nonsense, because the things in column 3 are side effects of being alive. I mean, they are the result of the accumulation of damage. They are parts of aging. So it's insane to suppose that we could actually address them by the same kind of means that we would address an infection. There's a second thing, however, that the relocation of that big black line tells us, which is that not only are the things in column 3 completely different from the things in column 1, but also they're not at all different from the things in column 4. There is absolutely zero biological distinction between the things in column 3 and the things in column 4. The only distinction is semantic. The things in column 3 are the aspects of aging that we have chosen to give disease-like names to, and the things in column 4 are the ones that we have not. That is all. And that turns out to be rather a useful insight when it comes to figuring out what to do about the things in column 3 and indeed the things in column 4. If you make that mistake, if you put that black line in the wrong place, this is what you end up doing: geriatric medicine. Geriatric medicine we may as well define as attacking the pathologies of old age directly, in the same way that we might attack an infection directly, trying to eliminate those pathologies from the body. And you only need to spend about a millisecond looking at this tiny little diagram to understand how completely brain dead that is. Metabolism is continuing to operate in old people. Therefore, the damage is continuing to accumulate in old people. Therefore, by definition, anything that attacks the consequences of that damage, the pathologies, is going to become progressively less effective as the patient gets older. It's just complete. I mean, a child could see this. It's insane that we spend so much effort on doing this, but that's what we do. Now, I am not the first person to point this out, although I may be doing it in somewhat more strident language than most people. The thing is that for more than 100 years, a few people, have actually noticed this. And they've said, well, okay, there's only one thing that we can actually do to keep people healthy in old age, and that is to intervene at an earlier point in this chain of events. And that's where gerontology came from. The whole field of studying the biology of aging came from that insight. At the end of the day, it's a reasonable insight, because let's face it, if we look at the living world, we see a lot of variation in the rate of aging, the rate at which metabolism generates damage. Different species age at very different rates. Even within a species, different individuals age at slightly different rates. So the idea was, well, maybe if we study this really hard, we can figure out what's going on. We can actually understand the nature of the creation of damage well enough that we can develop therapies, which we could apply to clean up our metabolism, to slow down the rate at which metabolism generates damage in the first place. If we can do that, fantastic. We will be postponing the age at which damage reaches this pathogenic level of abundance. Unfortunately, the gerontology approach to attacking aging has also been spectacularly unsuccessful for a completely different reason than the geriatrics approach, namely this: metabolism is rather complicated. This here is a simplified diagram of a small subset of what we know about how metabolism actually works. And as you can see, it's a bit of a mess. Those of you who write software, or who have ever written software, will immediately see that this is the ultimate, nightmare of uncommented spaghetti code. There's no way in hell that we are ever going to be able to tweak this system so as to stop it from doing the thing we don't want it to do, i.e. the creation of damage, without at the same time having, unintended consequences that stop it from doing the things we need it to do to keep us alive. Not going to happen. So that's a bit of a shame. And in fact, by the 1970s or so, people who were studying the biology of aging had more or less come to that conclusion, and they'd more or less given up. They had come to the state that, aging is bad for you. They were a bit like seismologists. People who study earthquakes, they understand that earthquakes are bad for you, but they don't have any actual aspiration to doing anything about them, right? You just kind of try to get out of the way. And it's the same with gerontology in the 70s and 80s. And it kind of stayed like that for a while. But the thing is, it shouldn't have, because there is a perfectly simple and really pretty damned obvious third option that escapes the problems of the geriatrics approach and the problems of the gerontology approach. If we want to break this link between metabolism and pathology, we do not need to break either of the components the component processes. We do not need to stop damage from generating pathology the way geriatricians are trying to do, and we also don't need to stop metabolism from generating damage the way the gerontologists originally tried to do. Instead, we can fix the damage. We can just go in and periodically repair this damage, eliminate it from the body. If we could do that, then we can leave metabolism alone. We can let metabolism generate damage at the natural rate, which means, of course, that we don't need to understand metabolism any better than we already do. And, moreover, we don't need to understand pathology either. We don't need to worry about how complicated life is late in life, because the fact is we won't let damage accumulate to the level of abundance that causes these pathologies. We will sit in that window of opportunity where the body is set up to tolerate a certain amount of damage. That's all we need to do, the maintenance approach. Sounds spectacularly simple, doesn't it? And actually, to be perfectly honest, it is. Because the fact is we already do that for simple non-living machines. This car, of course, is more than 100 years old. And the reason it's working just as well as it was when it was built, rather than having fallen apart at the age of 10 or 15 the way it was supposed to, is simply because it has been owned by crazy people who do a spectacularly large amount of maintenance on it, a comprehensive job of preventative maintenance that simply removes the damage before anything happens, like the doors falling off. That's all it is. And because aging is a consequence of physics and is fundamentally the same thing in a car as it is in you and me, we should, in principle, be able to do exactly the same thing in the human body. So the question then is, can we in fact do exactly the same thing? And the answer is, it looks as though we probably can, and I will explain why in a minute. But first of all, I just want to tell you why you hadn't thought of this. The fundamental answer is because since the dawn of civilization, we have been terrified of aging. We have all known that aging is this utterly ghastly thing that is going to happen to all of us if we get away with life for long enough and don't get eaten by tigers or whatever. And at the end of the day, we have to put it out of our minds and get on with our miserably short lives and, make the best of it, and not be preoccupied by this terrible thing. And people have been saying since the dawn of civilization, oh, I know how to fix aging, and they've always been wrong. So if you see someone like myself up here saying that this time it's going to actually happen, clearly you don't want to get your hopes up. You don't want to do that, especially because you have made your peace with aging. So you end up in a position where you make up these stories that try to convince yourself that aging is some kind of blessing in disguise. And this was perfectly rational until people like myself started coming along and explaining how we might actually bring aging under medical control. But now it's a huge part of the problem. It slows us down. It is the fundamental disconnect in healthcare today. Now, I've done a lot of pontificating so far, and I've only got 4 minutes and 11 seconds left, so I'd better talk about the biology, really. The fact is that even though the maintenance approach is vastly more rational and more promising than either the gerontology approach or the geriatrics approach, nevertheless, it's still not very easy. Because, let's face it, the body is a really, really complicated machine, and it accumulates a lot of different types of damage. And we've got to fix them all, just in the same way that a mechanic has to fix all the types of damage of a car in order to keep it on the road. And this is what we have to fix. It turns out that, yes, damage is complicated, but it's not nearly so complicated as you might fear. All of the various types of damage that we have to worry about, these intermediates, if you like, between metabolism and pathology, can be classified into just 7 major categories, which are listed on the left-hand side of this table. Things like cell loss, which is simply the phenomenon of cells dying and not being automatically replaced by the division of other cells. That's all that. Now, that's cell loss, and of course it causes various aspects of aging, like Parkinson's disease, because of the loss of dopaminergic neurons. And the repair for that, you all know what it is, it's stem cell therapy. That's exactly what stem cell therapy is. Put cells in that have been programmed to know what to do, to divide and differentiate into replacements for the cells that the body is not replacing on its own. The reason why SENS Research Foundation exists is because the other 6 categories of damage are not nearly so well understood by society at large. And there isn't nearly as much work as there needs to be going on to actually develop the corresponding therapies. But the point is there are corresponding therapies out there. All of the things I'm listing on the right-hand side of this table are within reach. We have made very nice progress. I'm going to be talking about that in a minute. Here we go. This is some of the stuff that we've done over the past few years, really unlocking huge logjams that have existed for more than a decade in the research to actually develop these repair therapies. It's all happening. I'll go back and show you this a little bit. This is a paper from 4 years ago, which is essentially a reinvention of the ideas that I'm putting forward right now and that I first published 15 years ago. And this paper, unlike the work that I originally published, is being actually paid attention to. This has now become an extremely mainstream orthodox idea, so it's not something that you need to think is some kind of heresy anymore. Furthermore, the fact is, this is not about longevity. If you look me up in the media, you will find that I get called the prophet of immortality and things like that. And this is rather distressing, because the fact is, it's a distraction. It stops people from taking this work seriously. So I want you to know that this is just straightforward, down-to-earth medical research. We do not work on immortality. We don't even work on longevity. We just work on health. And the fact is, like any other type of medicine, it will have a side effect, which is people will on average live longer. But that's a good thing, right? The fact is, this will actually cause people to live a lot longer because of the ubiquity of aging. The fact is, people in their 20s and 30s don't have much of a risk of death. The mortality rate in the 20s in the Western world is about 1 in 1,000 or less, which means that if we didn't have any aging at all, then people would live 4-digit lifespans on average. And, that's quite nice to think about. But it's also something you can make lots of science fiction about. And I don't want you to be distracted by that. I want you simply to think about the fact that this is healthcare and that you don't want to get Alzheimer's, and indeed you don't want anyone else to get Alzheimer's. And the way to stop us from getting Alzheimer's is not to treat it as an infectious disease, but rather to treat it as what it is, namely an aspect of aging. I'm going to close by just pointing out that this is coming soon. Maybe not for 20 years, but the widespread understanding that it is coming sooner than that, a lot sooner. Work in the laboratory over the next few years, I believe, has a high probability of being sufficiently successful to get the expert community in general on side with the idea that we can, in fact, bring aging under comprehensive medical control in the foreseeable future. And that's what you guys need to be waiting for. You need to be watching out for the widespread acknowledgement and anticipation that these therapies are coming. At the moment, it's still a relatively minority attitude, at least in terms of what people say in public. People will not, on average, be getting up on stage and saying the kinds of things that I say, but in a few years they will be, and you'd better be ready. I am going to finish just by saying that if you want to know more about the details, about the science underlying this, you should get this book, which I wrote several years ago. People keep saying, no, please update it, but the fact is it doesn't need much updating, not because there's been only a small amount of progress. There's been masses and masses of progress. The reason it doesn't need updating is because the progress has been all pretty much exactly what I said it was going to be. No, seriously. I mean, 15 years ago, there was a 7-point plan. There were 7 types of damage and 7 corresponding generic approaches to fixing it, and it's the same plan now. That plan has stood the test of time. And that, of course, is extremely good news. It means that we have a very good reason for confidence that we are on the right lines here. So that is all I have to say. Thank you very much.